Forced deadlock. Summary. This attack attempts to trigger and exploit a deadlock condition in the target software to cause a denial of service. A deadlock can occur when two or more competing actions are waiting for each other to finish, and thus neither ever does. Deadlock conditions are not easy to detect. Attack execution flow. The attacker initiates an exploratory phase to get familiar with the system. The attacker triggers a first action, such as holding a resource, and initiates a second action which will wait for the first one to finish. If the target program has a deadlock condition, the program waits indefinitely, resulting in a denial of service. Attack prerequisites. The target host has a deadlock condition. There are 4 conditions for a deadlock to occur, known as the Kaufman conditions. R25-3 Ref. 6. The target host exposes an API to the user. Methods of attack. Analysis. API abuse. Examples. Instances. An example of a deadlock which may occur in database products is the following. Client applications using the database may require exclusive access to a table, and in order to gain exclusive access they ask for a lock. If one client application holds a lock on a table and attempts to obtain the lock on a second table that is already held by a second client application, this may lead to deadlock if the second application then attempts to obtain the lock that is held by the first application. Probing techniques. The attacker can probe by trying to hold resources and call APIs which are directly using the same resources. The attacker may try to find actions, threads, processes, competing for the same resources. Solutions and mitigations. Use known algorithm to avoid deadlock condition, for instance non-blocking synchronization algorithms. For competing actions use well-known libraries which implement synchronization.